Hey physics peeps, we're going to start today with finding resultants in x and y components. But this first video is going to focus on finding resultants. And what we need to be able to do is identify and draw a resultant vector, and then use Pythagorean theorem to solve for the magnitude of the resultant vector. When we go through this today, you need to make sure that you have a calculator of some sort, whether you're using a calculator like this. And for this part, you need to make sure that you know where the square and the square root button is. But if you're using another calculator, like a web-based calculator or your phone, just make sure that you're aware of where those things are as well. You're going to have to flip it sideways and make sure that your little flip lock is turned off. Then, when we talk about vectors, all vectors can be added together in the same way that we've done our other vectors, where we added them tip to tail. And when we add things tip to tail, like add one vector to another, distances give us a displacement where we go from start to finish. But we can also think of this in terms of forces. Forces do the same thing. Forces, they add up to net forces. Velocities just give us a resultant velocity. But we call this thing that we were working on with displacements, for anything, we call it a resultant. Say that with me, resultant. And so resultant is just the shortest path to get from A to B or from start to finish. It doesn't get added tip to tail like your other vectors do. The resultant goes from start to finish. But we also use Pythagorean's theorem to solve out for that resultant, because many cases we know what the components are. And if we know what the components are, we can solve for our resultant, which ends up being the longest side of a right triangle, because that's what all of this ends up making. That's cool. And Pythagorean's theorem just relates the three sides of the triangle, A, B, and C, in this mathematical formula. A squared plus B squared equals C squared. And if you've had Pythagorean theorem or done Pythagorean theorem in math class already, you're probably familiar with this. If you have not have it, what you really need to know is that C is the longest side. I want you to copy this equation onto your sheet of paper, and I want you to make sure that you label C is the longest side. This is also referred to as the hypotenuse. And hypotenuse. But you're going to use Pythagorean theorem if you're given two sides of a triangle and you need to solve for the third. Let's take a look at some examples of what you might run into. Oops. So here it says determine the resultant for the following components. When we do this, they give us a diagram here that has an arrow going here to the right, an arrow going up. This arrow represents 4 meters, this arrow represents 3 meters. And so in order to determine the resultant for these components, I need to copy this onto my sheet of paper. And when I'm copying it, I want to make sure that it represents the same size and direction of those vectors. So when you're copying it, just one arrow is going to the right, one arrow is going up. I'm also going to label them just as they are. One here is 4m, and the m is meters, and one is 3 meters. But now I'm going to draw my resultant, or my displacement. Remember that these two are are about the same thing. But when I draw my resultant, it needs to be going in the correct direction. It needs to be an arrow. So drawing out something like this, that's not good enough. And it is also not drawn like this. This is going from finish to start. That's not a resultant or displacement. Resultants always go from start to finish. like as if it was walking on a path. Okay? So we copied our vectors, we drew the resultant. Now we're going to look at what we have. And what we have are two sides of a triangle. And what we want to actually figure out the magnitude of this resultant. We need to figure out the size of it. It's the other side of the triangle. Because I have two sides of a triangle, and I have one side that I'm looking for, the equation that I use is Pythagorean's theorem. It's a squared plus b squared equals c squared. And when I'm solving this out though, remember that c, it's the longest side. And on this triangle, and what we do most of the time, it is this side that I just drew. It is the resultant. So that's what I'm going to look for. I'm going to leave that as c squared. I'm going to put my other values to represent the other sides. One is a, one is b, but it really doesn't matter which one's which. You just kind of choose. In this case, I put 4 and squared and 3 squared. I have to keep the squared in the equation. I'm just replacing the a and b with the values that are up here. And now these values are things that I could do in my head pretty quick, and if you want to use your calculator, that is fine. But there are other times where when we do these calculations, you don't have really nice numbers, and using the square button, you just got to make sure that you use the square button on your calculator. So here we got 4 squared. That's the same as 16 plus 3 squared. 3 squared is 9. It's equal to c squared. I'm going to keep simplifying this until I get down to what I'm looking for. I'm looking for the side c. So 16 plus 9, that equals 25 equals c squared. Just be careful, I can't stop here. This isn't my answer. I'm not just looking for c squared, I'm looking for c. So I have to undo a square by taking the square root of both sides. So on your calculator, make sure that you know how to do the square roots. But when I do that, c is equal to 5. 5 is the square root of 25. Okay? So here's part of my answer. I worked through, I drew my resultant. I found that I had 2 sides of the triangle. I'm missing the third. That's why I'm using a squared plus b squared equals c squared. And I run through and put in my values of a and b. I'm solving for c. I get this. But when we get here, we also need to have a unit. Our unit is the same unit as what we worked with up here. If these were in meters, my answer is in meters. If these were in newtons, my answer would be in newtons. If it was meters per second squared, it's meters per second squared, joules, all that stuff. But that's kind of what you would put in for your units. Then let's take a look at another example. And for something like this, I'm going to ask you to copy this one onto your paper. 15 newtons, negative 90 newtons. This is these represent forces that somebody is pulling on. It's maybe one person's pulling this way and one person's pulling this way on something. But this is negative 90 newtons because it's pulling down. So when I need to determine the resultant, first thing I do is draw it. Resultants always go from start to finish, and my arrow has to be pointing the correct way. Remember that it doesn't get added, it doesn't connect tip to tail like the other ones. This one's tail to tail, this one's tip to tip. It's these two that are tip to tail. The resultant is different. But then, because I have 2 sides and I'm looking for the size of the third, I need to use Pythagorean's theorem. A squared plus b squared equals c squared. When I put this in though, remember I'm looking for side c. It's the longest side. And then I'm putting in the other values. It doesn't matter which one goes where, but what you need to be careful of is how you put this one into your calculator. Because when you put this on your calculator, negative 90 squared, if you come up with negative 8,100, you got to be careful how you entered that on your calculator. Because if you square a negative number, you really should end up with a positive. Sometimes your calculator will be doing this. When you enter it, it'll take negative of 90 squared. That's not what you want. So if putting things, or if you're able to put parentheses on your calculator, what you can do is put negative 90 in and square it. Or just forget about the negative, and that's fine too. And because the negative really is just telling direction, and here we don't have to worry about it. And so we should end up with positive 8,100 when we square negative 90. And then plus. And now we take 15 and square it. You end up with 225 equals c squared. Now I'm just going through and simplifying everything. I have 8,325 equals c squared. And the last thing I do to get c by itself, I have to square root. Okay. And so I get c plus 8,100 and square root, second answer. My answer for c comes out to be 91.24. When you get your answers, go out 2 or 3 decimal places, that's fine. And so this is my answer, but I also need a unit. My unit is whatever I was working with up here. Because that was in newtons, my answer here is in newtons. I want you to pause the video and do this one on your own. See what you come up with for the resultant. All right, check your answer. And if you did this right, this should be how you draw the resultant. This wasn't shown up as negative, but that should be negative. But anyways, you're not going to be asked to necessarily fix mistakes like that. But whether this is negative or if it's positive, you should end up with the same answer here, 0.71. Our units are meters per second, and that's our answer for C. And so this arrow represents 0.71 meters per second. And this is used a lot for navigation, especially with things like airplanes or submarines or other things where you might not be just traveling in one direction. You might also have things like wind that is pushing you in another direction as well. But what we say, your resultant vector is this one that we drew. And because if an airplane is actually traveling east and it's pointing straight east, but there's a wind pushing it south, its path would actually follow this path or this arrow. And so there's corrections that they end up making for their paths as they travel from one place to another. But hopefully this was helpful, and feel free to talk to your teacher if you have other questions. Good luck with everything. We'll see you guys here in the next video.